Hello everyone, it's Jay, and today we'll be going through problem 1A on the pre-workshop, which is to balance this reaction. So, the method we're going to use to balance reactions in this class is called the 6 method. And the way that the 6 method works is we place a 6 coefficient in front of the molecule with the most elements. And the reason we do this is because it allows us to eliminate fractions of a half, a third, or a sixth that we may get while balancing in our coefficient. And I should note that you don't have to use a 6. Some people like to use an 8 or a 10 as well. This is why we use the 6, and we will be teaching it with the 6. So let's go through the process. So the first step in using the 6 method is actually exactly what I described. So this is actually our step 1. So we're going to place a 6 in front of the molecule with the most elements. We have C5H12, CO2, and H2O are all candidates. They all have 2 elements. And in those cases, we're going to pick the most complex looking molecule. So here, clearly, C5H12 looks the most complex. So let's put a 6 there. And now we're ready to move on to step 2. So step 2 is to balance for an atom that appears in only one more molecule without a coefficient. So let's do that for this, and that will make step 2 much more clear. So here we have carbon and hydrogen, and if we see here, we have 6 times 5, or 30 carbons, because we have 5 atoms of carbon per molecule and 6 molecules, and we have 6 times 12, or 72 hydrogens. So we want to look for molecules that have that only appear in one more molecule without a coefficient. So let's see if carbon does. Carbon only appears in CO2, so CO2 doesn't have a coefficient, great candidate. And actually hydrogen also applies, it only appears in H2O, and that also doesn't have a coefficient. So for now, we're just going to use CO2 arbitrarily. So 6 times 5, 30 carbons. Each CO2 has 1 carbon, so we want 30 CO2. All right, great. Now let's repeat that for hydrogen. 6 times 12 is 72 hydrogens. H2O, each H2O has 2 hydrogens, and we want 72 on that side, so we want to put a 36 here. That gives us our 72 hydrogen. Now, all we have left is O2, but O2 appears in CO2 and H2O. So let's add up these 2 oxygens, and we can figure out how many we should have on our left side. So 30 times 2 for CO2 gives us 60 total oxygens in CO2. 36 times the 1 gives us 36 total in H2O, so we have a total of 96 oxygens on this side. So we must have 96 oxygens here. In order to do that, we will have 48 O2, because 48 times 2 is 96. Great. So now we need to move on to step 3. And step 3 is to reduce coefficients. And in order to reduce coefficients, we were going to use the greatest common factor. And the greatest common factor is the number that divides all of our coefficients, and in every case that will yield a whole number, and we want that to be the biggest possible number. So in this case, 6 is our greatest common factor, because that is the biggest number that divides 6, 48, 30, and 36. So let's divide through by 6. So 6 divided by 6 is 1, and when we have coefficients of 1, we leave them blank. 48 divided by 6 is going to be 8. 30 divided by 6 is going to be 5. And 36 divided by 6 is going to be 6. So we tentatively have our balanced reaction, and then step 4 is always just to check that atoms are balanced. So we have 5 carbons here, 5 carbons here. were balanced for carbon, 12 hydrogens here, and then 6 times 2, or 12 hydrogens here. We have 8 times 2, or 16 oxygens here. That's split among 5 times 2, or 10 oxygens, and then the 6 times 1, which is 6 oxygens. So here we have 16 oxygens as well. So we have finished our balancing process, and our final reaction is C5H12 plus 8O2 gives us 5CO2 plus 6H2O. Thank you so much for watching.